So this is more of using the inverse functions to find these different values. Recall that when you take the inverse of something, you take the inverse of the ratio and it gives you back out the angle measure. And when you take the trig function of the angle measure, then it pops out the ratio. So like on this one, it's tempting to say that the arc sine of 5 pi over 4, oh well, arc sine and sine just cancel each other out, and thus that's 5 pi over 4. However, that's not the case, because if you recall, arc sine has to be, you can only put in numbers into arc sine between negative pi over 2 and positive pi over 2. But 5 pi over 4 is not between negative pi over 2 and positive pi over 2. So thus, you can't just cancel those out and say that it's 5 pi over 4. This can't be 5 pi over 4 because the output for, so the range, the numbers that come out for arc sine, so after I evaluate this ratio, the arc sine of that ratio must be a number between here and here. 5 pi over 4 is not a number between negative pi over 2 and positive pi over 2. So if I actually go through and I calculate this, remember that this is going to give us some kind of a ratio. So I'm asking myself, well, 5 pi over 4, what's the sine of 5 pi over 4? Well, reference angle there is pi over 4. That's in the second quadrant. Sine's positive. So that's going to be root 2 over 2. Again, unit circle, critical to know, really know. So then the arc sine of root 2 over 2, only between negative pi over 2 and positive pi over 2, must be talking about the first quadrant here, and thus we have a reference angle of pi over 4, and our angle measure will also be pi over 4. So notice how pi over 4 is a number between negative pi over 2 and positive pi over 2, because we're only allowed to have it in these two areas for the arc sine. So what if we want to know, well, what's the sine of the arctangent of 1/2? Again, I know 1/2 looks like it's on the unit circle. It is for sine and cosine, but there's no sine divided by cosine that's on our unit circle that we know, not that we don't know it, but what am I trying to say? I'm trying to say there's no sine divided by cosine that you can take on our unit circle right now and know what that angle measure is off the top of your head and give us a 1/2 for the arctangent. So thus, here arctangent is going to give us an angle measure, theta. I don't know how big that is. It's not something that's a nice 60 degrees or 30 degrees or 45 degrees or any denomination of those. It's something else. What it is, I don't know off the top of my head. It doesn't matter. But arctangent is not defined in the first and the second quadrant, or second and third quadrant. And since this 1/2 is positive, I'm going to have to throw it in the first quadrant here. So here's the angle measure, this unknown angle measure amount. Did you notice that I made a right triangle? Okay, but that's our angle measure. And tangent is a ratio of opposite to adjacent. So the opposite side is 1, the adjacent side is 2, and well, no wonder why I didn't recognize it. This isn't a 30, 60, 90 triangle or a 45, 45, 90 triangle. So if I use Pythagorean theorem to figure out how long the hypotenuse side is, 2 squared plus 1 squared is 5, and then I got to square root that. That hypotenuse side is square root of 5. Again, I don't recognize this triangle. I could figure out how big that angle is, but it's really unimportant. I just want to know what's the sine of that angle. Well, the sine of that angle, whatever that angle is a ratio of opposite to hypotenuse. So that'd be a ratio of 1 to square root 5, which is root 5 over 5. And sine is positive in the first quadrant. So there's a sine of the arctangent of 1/2. So let's find the exact value of the cosine of the arc sine of negative 1/3. Again, this is not on our unit circle. Okay, I don't know. Sine of what angle gives us a ratio of 1 to 3? I don't know off the top of my head. So if I think about graphing that, okay, arc sine. Remember, this is going to give us an angle measure, and we'll eventually figure out what the cosine of that angle measure is. So arc sine, only in the first and the fourth quadrant. And this is a negative 1/3 here, so that must mean we're in the fourth quadrant for that arc sine. So here's my angle. Don't know how big it is, doesn't matter. but I do know that the ratio of the opposite to the hypotenuse side has to be a ratio of 1 to 3. So the opposite is 1, the hypotenuse side is 3. Now think about that. Where does a negative go? Well, it's never going to go on the hypotenuse. It's either on the x part or the y part. It makes sense here to put on the y part because to get to this coordinate, I had to go to the right some positive amount, and then I had to go downward some negative amount then. Then if I do Pythagorean theorem to figure out how long this other side is, let's see here. 3 squared is 9, take away, take away a negative 1 squared, and that would be an 8, and I square root that, so square root of 8, which is 2 root 2 for that side, and that should be a positive 2 root 2 because it's headed to the right to get to this coordinate. So now I want to know, now that I know what this triangle looks like, this right triangle, I want to know, well, what's the cosine of this particular angle? Well, the cosine is a ratio of adjacent to hypotenuse. So the adjacent side was positive 2 root 2, hypotenuse side is 3, there's the cosine. As a double check, all students take calculus, cosine better be positive in that quadrant, and the cosine of this angle is in fact positive. So let's find the exact value of the tangent of the arc cosine of negative 1/3. So thinking through this one, arc cosine, that's going to give me an angle measure, and I want to know what's the tangent of that angle measure. Arc cosine, first and second quadrant, must be in the second quadrant, all students, because of that negative there. And I've got a ratio of, so my angle is actually this angle right there, but I'm going to use this reference angle to help me figure out what the arc cosine of that angle, or what that angle measure is. That gives me an arc cosine for negative 1/3. In any case, this is the ratio of adjacent to the hypotenuse side. So adjacent is 1, hypotenuse side is 3. Think about, how do I get to this point? Oh, I got to go negative 1 over and then some positive amount going upwards. So then this is my angle. So the tangent of that angle, well, I'm going to have to figure out how long the other side is. Again, that side will be, I think that's a 2 root 2 again. Yeah. 9 take away 1 would be an 8, and square root that. Yep, 2 root 2 is what that simplifies to, and that should be a positive 2 root 2. So the tangent ratio, opposite over the adjacent, would of this angle measure would have to be 2 root 2 over a negative 1, which gives me a negative 2 root 2. And I'm recalling, oh yeah, sine's the only thing that's positive in that quadrant, which is why my tangent is a negative here. Next one. So let's find the exact value of these ones. So I'm thinking that this is like, but this time we're doing cotangent rather than tangent. It acts very similar to cotangent, but let's talk about this arc sine. Okay, I want to know what the cotangent of this particular angle is. So if I draw arc sine of 4/5, let's see here, that's a positive 4/5. So there's our angle, which is also a reference angle here. Okay, but there's our angle. And that's a ratio of opposite to hypotenuse. Oh, it's a 3, 4, 5 triangle. All of those should be positive. So to get to this point, I have to go positive this direction, positive that direction. So then to figure out the cotangent, well, I'm always thinking about the tangent before I think about the cotangent. The tangent of this angle is opposite over adjacent, so that'd be 4/3. Now I could tell you what the cotangent of this angle here has to be, and that's going to be a ratio of 3/4 then. Okay, I don't think this is too bad today. I'm going to have you guys try this one. If you've done it correctly, then you should get the solution of root 13 over 2. If you're getting stuck, then draw this triangle in the first quadrant, and then you need to find the cosine and then take the reciprocal of the cosine of that angle. And the last one, but not least here. First of all, this root 6 over 6, excuse me, you know what? That was originally a negative 1 over root 6. So if I think about that, and then I draw this in, draw the arc sine, but it's got to be negative, so we're talking this quadrant down here. So this is definitely going to be a negative angle there by the end of it. All right, figure out that angle and then take the cosine of that angle. So that angle, let's see here, if it was 1 over root 6, that means the opposite side was 1 and the hypotenuse side is root 6. Opposite side was 1. One of these has to be negative. It's got to be that one. And then this other side, well, if I take 6 squared, Pythagorean theorem is what I'm doing right now. 6 squared, or root 6 squared is 6. Take away negative 1 squared is going to be square root 5. So then to do the cosine of this angle, adjacent to hypotenuse, that would be a root 5 over root 6, which is, when I rationalize that, I get root 30 divided by positive 6. And just to double check myself, all students take calculus. Okay, cosine has to be positive in that quadrant, and I do have a positive ratio. That's actually all that I have for you guys. So pretty quick lesson today. I hope that this makes sense. And this is April Rainey signing off.